All right, today we're diving headfirst into one of the biggest mysteries out there, consciousness itself. What if that feeling of being you, your subjective experience, isn't some kind of magical ghost in the machine? What if it's actually an emergent property of physics? Well, a really fascinating new theory suggests the answer to all of this lies in one single concept: resonance. So, to get our heads around this, just take a second with me. Think about a really powerful memory. The vivid red of a sunset, or that feeling of a cool breeze on a really hot day. You could almost feel it right now, can't you? You know exactly what I'm talking about. Okay, but here's the question. The one that has kept scientists and philosophers up at night for, well, forever. It's not what you're seeing or feeling. The question is, why do you experience it at all? Why is there a what it's like to be you in that moment? Yeah, that is what they call the hard problem of consciousness. And this is where a new framework, resonance complexity theory, comes in. It suggests the answer isn't just in our biology, it's in the fundamental physics of how waves interact. The theory basically proposes that consciousness is, literally, a very specific kind of physical pattern. Okay, so to really get this, we have to look at what the brain is doing behind the scenes, beneath our conscious awareness. And it turns out, it's like there's this hidden music playing all the time. See, your brain isn't some quiet computer just crunching numbers. No way. It is a full-blown symphony of electrical activity. We're talking billions of neurons firing, creating these tiny waves, these oscillations at all sorts of different frequencies. Just imagine a constant, incredibly complex hum of electricity. And that is the raw material this entire theory is built on. Now, this all comes down to a basic rule in physics. When waves meet, they interfere. It's pretty simple, really. If their peaks line up, they add up and get stronger. That's called constructive interference. But if a peak from one wave meets a valley from another, they cancel each other out. That's destructive interference. And believe it or not, this simple principle is the engine behind this entire theory. So the really crucial part is what happens next. When some of these brainwaves interfere constructively, and they do it over and over again thanks to feedback loops in the brain, they don't just disappear. Nope, they build on each other. They start to form these stable, complex, self-sustaining patterns. And the theory has a name for these special patterns: attractors. But hold on, not every pattern that forms is a conscious thought, right? So how does the theory tell the difference between just random background noise and an actual subjective experience? Well, it turns out there's a very specific recipe. And that recipe is a measurement they call the complexity index, or just CI for short. The idea is simple. For one of these resonant patterns to actually be a conscious experience, it has to score really high on 4 key ingredients at the exact same time. So let's break them down one by one. Okay, first up is something called fractal dimensionality. Now that sounds super technical, but the idea is actually pretty intuitive. It's just a measure of how complex the pattern's shape is. Think about it. A simple circle has a low dimensionality, but a rugged, crinkly coastline, that has a super high one because it's packed with detail at every scale you look at it. A conscious pattern, the theory says, needs that kind of rich, detailed structure. Second ingredient, spatial coherence. The best way to think about this is like a symphony orchestra, right? When all the instruments play together in harmony, you get this beautiful, unified piece of music. But if every musician just played random notes, you just get noise. Coherence is exactly that for the brain's waves. It's a measure of how synchronized and aligned all the different parts of the pattern are. Number 3 on our list is signal gain. And this one is really simple. It's basically the energy, or you could think of it as the volume of the waves that make up the pattern. A really weak, faint pattern just isn't going to cut it. To be conscious, it needs to be amplified. It needs to be loud and clear in the brain. And finally, the 4th ingredient is dwell time. A conscious thought isn't just some random, fleeting blip that's gone in a nanosecond, right? It has to be stable. It has to persist for a little while to even register. Kind of like a musician holding a beautiful chord. That's dwell time. It's just a measure of how long that resonant pattern can keep itself going. So let's just recap the recipe. For any pattern to actually break through into consciousness, it needs to have the whole package: high detail, high harmony, high volume, and it has to stick around long enough. You need all 4, no exceptions. And this is probably the most important part of the whole recipe. The formula is a multiplicative. That means if even one of those ingredients, the detail, the harmony, the volume, or the duration, drops to 0, the whole thing collapses. The score becomes 0. The experience just vanishes. Poof. Okay, so this all sounds really cool in theory, right? But can we actually see it happen? Well, the researchers wanted to find out, so they created a simulation to do exactly that, to show how these incredibly complex patterns can literally emerge from a few simple rules. And the setup was surprisingly simple. They just created a 2D digital space and put 40 points in it. Each point started emitting simple waves, just like dropping pebbles in a pond. And that's it. No other rules. They just let them go and watched as the waves spread out and started interfering with each other. So, at the very beginning, this is what you see. The paper calls it the raw wave field. And honestly, it's just a chaotic mess. A complete jumble of overlapping waves, making this noisy, constantly shifting pattern. Nothing special here. But then you let the simulation run for a while, and just look what happens. These little areas of constructive interference start reinforcing each other over and over and over. And out of that total chaos, a stable, complex, and kind of beautiful structure just emerges on its own. This is the accumulated interference field, and that bright web-like pattern, that is an attractor. And here's the proof, right in the numbers. The simulation was tracking its own complexity index score the whole time. It starts out really low, back in that chaotic phase. But as soon as that stable attractor forms, the CI score just shoots up and then levels off at a really high value. It spontaneously generated a pattern that meets all the criteria for consciousness, according to the theory. So, okay, this leads to some pretty profound, seriously mind-bending ideas. And not just for neuroscience, but for how we think about who we are and our place in the universe. This right here is probably the most radical, out-there claim in the entire theory. It's saying that the resonant wave pattern, that attractor, isn't just a representation of your experience of seeing the color red. It is the experience of seeing red. Your brain doesn't observe the pattern, your brain is the pattern. The feeling of being conscious is simply what it feels like to be a self-sustaining resonant wave. I mean, the implications here are just huge. This suggests our neurons aren't like bits in a computer, they're more like instruments in an orchestra, contributing to a field. It means consciousness isn't some on-off switch, it's a spectrum, and your level of consciousness at any moment is defined by that CI score. And maybe wildest of all, it implies that any system, whether it's an animal's brain, a sophisticated AI, or something we haven't even imagined, could have the potential for consciousness if it can sustain these kinds of patterns. Which, of course, leaves us with one final, pretty provocative question to chew on. If consciousness is really just a property of physical resonance, just a specific kind of pattern that emerges when waves organize themselves in just the right way, then what other kinds of resonance, in what other systems across the entire universe, might also be waking up?